this sort of test really highlights, this isn't like, oh, you should maybe insulate your house better. No, this tells you
this is
you've got an icy gale blowing through your kitchen.
Dirty great hole under your kitchen sink, and it needs fixing.
Today, we're looking at a technology that can be used on every property to change it from being like this to being more like this. Welcome to the Everything Electric Show.
If you like Everything Electric, then you will love our 6 live shows being held around the world in 2023, starting with Sydney in Australia on March the 11th and 12th. So, hi Dean, thanks for joining us today. It's very good of you. I just want to know really basically what is an air permeability test?
An air permeability test is a way of testing how leaky a house is. So, the principle behind it is, and all the theory is that you could have the best insulation in the world, but if there's a hole around the pipe that goes through the wall and all the air leaks out, you've wasted your money on the insulation. And it takes a huge amount of energy to warm all the air inside your house. And if that's constantly leaking out, especially when it's cold and windy in the middle of winter, it's going to cost you a fortune. It's going to be cold and drafty. You hear noises from outside more. It's not going to be comfortable, and it's going to burn a whole load of gas and CO2 emissions. And doing an air permeability test allows you to walk around the house. They basically put a fan on the front door and suck the air out. So it's like the negative. It's like the inverse of what normally happens.
Yeah.
So you can see what's happening. It makes it much more obvious.
You find where the leaks are. You would be sucking cold air into the house when you evacuate the air.
Yes, exactly. Right. And you can go around and see where all the cold air's coming in. You can feel where the air's blowing in, and seal the leaks up. And it's a cheap thing to do, and it's really effective.
So can we go and see what they're actually doing?
Yeah, let's go and have a look.
Ah, now I'm beginning to get the idea. So that's the front door.
Yes, yeah. Basically a really big fan, and how it works is we switch the fan on.
Right.
There's a red pipe and a blue pipe. They go out. One goes outside, one goes inside.
Right.
And those pipes measure the air pressure difference between the outside and the inside, while the fan's going, and using some really clever software and information that you input about the property.
Right.
It gives you a score,
right?
So then you know how leaky the house is, or not.
Right.
And from that you can calculate kind of energy cost and savings.
Right.
All sorts
and
of
could you then
stuff.
maybe temporarily block up the major holes that you found and try it again?
Absolutely,
and see what,
So we can work out exactly how much money is being saved by doing this, and we can kind of put some science behind it, get some numbers, and find out financially the kind of benefit for this.
Benefit of it.
Yeah,
fantastic. So how do we start that? Is there a switch somewhere to?
There isn't a big red button. Press that button.
Oh my God! So I'm not feeling anything yet, Dean. I mean, it feels other than I can hear the noise.
So the way we find out precisely where the leaks are coming from: close all the doors in the house while the fan's running, and open the doors one at a time. You see the pressure there? You feel?
Oh my God! That's not like a slight leak. That's wind coming through here.
Yeah.
So that wind's got to come from something, and it's cold. That is amazing. When you, that isn't a little bit of air. That's a lot.
So that we've identified there's some big holes somewhere in the kitchen. So a loft hatch is one of the key areas where a lot of air leaks out.
Right.
So obviously while we've got the fan running, we can see if we've got any air leaking through this one. And
I mean, I'm very confident we have.
We can already feel it actually.
That side of my head is colder already than that. That's amazing. So you give me this very, very high-tech piece of equipment.
Yeah, some high-tech stuff.
This will measure. Look at that.
Yeah. You see that?
Yeah, that is
blowing about.
Yeah. Incredible, isn't it? That is amazing, because you would not think that.
You wouldn't know
just
that.
Walked up. No.
And this is the beauty of doing the kind of the invert of what's happening. Sucking all the air out of the house through the door. It highlights things like this that you wouldn't otherwise be aware of.
Right.
Really, this is It's costing a lot of money.
It's costing a lot of money. But I mean, also to fix it, it's not like you've got to fit new windows or put a new door. This is very easy to fix.
Really low hanging fruit, low carbon footprint, low cost to the fix. It's a walk down to your local DIY store and buy some
sticky
sealant.
Some sticky
sealant
around
sticky
the
back
edge.
foam sealant and stick it on.
It would make a huge difference, because that is crazy.
Yeah.
That is really proper. Wow.
Yeah.
Amazing,
That's a lot of energy.
It is, isn't it? Yeah. So for people watching this now, is there some quick tips of just simple things they can do to help decrease the amount of cold air blowing in the house?
Yeah, definitely. Well, a quick summary is things like fireplaces, pipes through
wall,
walls. Yeah. Where you've got holes going through walls, bottoms of skirting boards quite often.
Right.
External doors, windows, light fittings. Yeah, obviously, there's quick fixes.
Yeah.
You can go down to your local DIY store, buy tape, masking tape, foam sealants. Try and get some old, that they're going to throw away, some silicone that you get cheap.
Right.
So, use that to seal around the bottom of the skirting boards.
Right.
It all makes a really big difference. Yeah. And then obviously be mindful of it in the long-term planning of home improvements and things like pin spots.
Yeah.
To avoid things like that.
But then the cost savings have got to be noticeable. I mean, that must be a really good thing if you've had your house tested and you go, right, I'm going to seal up the loft hatch, I'm going to seal up that back door, I'm going to make sure that's going right. Would you would not have noticeable energy savings?
Yeah. So from consultations we've had with the companies that produce the EPC energy certificates, we've estimated that from the trials we've done, we're looking between 10 and 20% improvement in energy efficiency.
Very noticeable. Yeah.
It's substantial. Yeah. It's definitely worth.
And if you spread that out over the whole country, you're looking at
enormous
staggering
amount of energy.
Savings. Yeah.
And money.
We're wasting so much money. Right. But then what about, so if you do seal your house up, and the one thing I'm thinking of is like condensation and no fresh air coming in your house. I mean, in the summer, it's not really a problem. You can have a window open. But in the winter, does that not have a kind of negative effect on the house?
It's a really good point. One thing that we're measuring with the air permeability is we're measuring uncontrolled ventilation.
Right. Yes.
And there's
might not know about at all.
Exactly that. Yeah. So things like extractors, we actually tape them up for the test.
Right.
So normally you trickle vents on windows, extractor fans, vents for boilers. Obviously you don't seal those up.
And cookers and all that sort of it. Yeah.
Yeah.
So this is a relatively new house. I'm assuming that I know new houses are being tested, but could you do the same test on an older property, even quite an old one?
Yeah. So any house, same rules apply, same physics applies everywhere. If you've got a hole, you've got hot air leaking out of it, you're losing money.
Yeah.
It's important to get on any type of property.
Right.
Yeah.
And can you get, because I'm intrigued to know what this house scores. I mean, do you know what the score is here?
The score on this house, we've seen the initial results looks around, it's about 8 to 9.
Right. Which is not terrible, is it?
It's not terrible. This is ironically a pretty good house, to be honest. And there are some key aspects to the actual construction methods specifically to this house that have helped a lot with that. And it's that it's got solid floor downstairs.
Right.
And it's got the traditional plaster. Sadly, a lot of the new build houses now are all the dot and dab plaster method. Right. So there's a gap behind the plasterboard and the blockwork, and it doesn't seal up.
Right.
And all the warm air kind of flows through the building envelope
and outside.
And leaks like a sieve. For some context around how good is a good score and how airtight is too airtight, the scores on average are estimated to be around a score of 15 across the whole of the UK.
Right.
Building regulations in 2006 said you have to score 10 or lower.
Right.
And it's now reduced that threshold down to has to be 5 or lower.
Right.
And it's quite an effort to achieve a score of 5 or lower.
Yeah.
The general consensus is that only below a score of 3 do you need to start worrying about air permeability.
That you might need to do something about it.
You need more ventilation.
Right, okay.
Yes.
So it's when your house is almost a sort of vacuum box, ultra sealed.
Obviously have to apply common sense and make sure you really need good ventilation.
Yeah.
But in a perfect world, you'd have a completely sealed house, but with mechanical heat exchanger ventilation, filters and everything.
Yeah.
Obviously, we're a long way from that at the moment, but this is a first step in
towards
that direction.
Yeah.
Some good news: regulation has changed recently. They have to test every new build house.
Right.
It used to be make one work and pass.
Right.
With the existing housing stock, obviously, a vast majority of houses in the UK are not new builds.
Yeah.
and the same physics applies to the house. So I think it's really important to have air permeability testing on those as well.
So if people want to have an air permeability test, where's the best place for them to head to find out more?
The best places at the moment, there's an organisation called ATMA, another testing body called Elmhurst, and they have a list of accredited air permeability tested engineers on their website. You try and find one locally.
Right.
Probably a good idea to point the engineers in the direction of this video to explain what they're wanting them to do.
Right.
Yeah, get a test booked.
So we'll put all the links to that in the show notes for this episode.
Yeah.
That's great. I mean, as you said, it is such a simple and cheap, real big change to your house and to your energy bills. The potential for it is amazing. I mean, some people might live in lovely houses that are really well sealed already, but I know some houses that definitely aren't, including mine. There's bits where I know we're leaking like mad.
We all know bits, and identifying those is really important.
Well, big thanks to Dina. It's been a really fascinating look at the process and the technology that isn't that well known when it really should be. I mean, we should all be having this done, and we should all be plugging the leaks in our houses. So thanks also to the testing team from Nats and our homeowners, Matthew and Ruth. All the links are in the description box below. And remember, all our home energy episodes are now here on the Everything Electric Show. And I really hope you've enjoyed this particular episode. Please do like, subscribe, and most importantly, share this episode so we can help more homeowners. And as always, if you have been, thank you for watching.